Number 6 says a 0.334 gram sample of an unknown halogen occupies 199 milliliters at 398 K and 1.41 atmospheres. What is the identity of the halogen? So this is kind of a weird question, and there's definitely one like this on the exam, and there's one like this on the homework. So we are given a mass of a sample, we're given some ideal gas law stuff, and we're asked for identity. That seems like something that's impossible to solve. But it turns out we're going to identify this halogen by its molar mass. So molar mass is usually something you just look up on a periodic table or Google. But in this case, we could experimentally find it because it's grams per mole. So we can mathematically find molar mass. And if we find the molar mass of this gas, we can identify is it fluorine or chlorine based on the molar mass of each of these things. So that's basically that. So what we need to do is we need to find grams and we need to find moles. Well, it turns out finding grams is super easy because it tells us a 0.334 gram sample. So we know we have the mass of 0.334 grams. But we do not have the moles. How do you think we're going to find the moles? Well, there's where the ideal gas law comes in. PV equals nRT. In this case, our variable is n, so I want to divide both sides by RT, and I find that n equals PV over RT. Now, as we've done in several previous examples, we need to make sure that all of our variables are in the right units. So the pressure needs to be in atmospheres, the volume in liters, R is a constant, and the temperature needs to be in Kelvin. So now we can plug in what we know. First, the pressure, which is already in atmospheres, so I can put in 1.41 atmospheres, times the volume needs to be in liters, but I'm given 109 milliliters. I need to divide that by 1,000. So 109 divided by 1,000 is 0.109 liters. R is a constant, 0.08206. That's liter atmospheres per mole K in the interest of space. I'm not going to write all that. And the temperature needs to be in Kelvin, and it is given in Kelvin. So now we have 398 K. And when we do that math, we find that the number of moles is 0.00471 moles of this unknown halogen. Well, now I could experimentally determine the molar mass. I know moles and I know grams. So let's divide. Molar mass is the grams from the problem, 0.334 grams, divided by the moles, which is 0.00471 moles. And when I do all that math, I get 71.0 grams per mole. Well, which diatomic halogen has a molar mass of 71 or close to it? Well, each chlorine is 35.45. When you do that together, you get 70.9, which is very close to 71. Fluorine is 19, so you would get 38 as its molar mass. Okay, so the answer here is Cl2.